Assalamu alaikum. This is Dr. Saeed Ali Hamza. I was requested by one of the student or one of the candidate to make a video on how to calculate the aortic valve area by continuity equation. First of all, you should know what is continuity equation. Continuity equation is based on a law of conservation of mass that states that amount of blood flow or amount of flow of liquid at one point of a closed tube or a structure is equal to the flow at another point. For calculation of aortic valve area, we can state that the flow at LVOT is equal to the flow at aortic valve. This is continuity equation. What is flow? How can we calculate that? We can calculate the flow by multiplying cross-sectional area at that point with VTI at that point. How can we find the VTI? We can find the VTI of LVOT by applying pulse wave Doppler in 5-chamber view on LVOT, and we can get VTI at LVOT. And for finding the VTI of aortic valve, we can place the CW Doppler, continuous wave Doppler, at aortic valve, and we can find the VTI envelope of aortic valve. Or we can also place or put the values of velocity in place of VTI. So flow can be calculated by multiplying cross-sectional area and VTI, or in case of velocity, cross-sectional area multiplied by velocity. So the flow at LVOT will be equal to cross-sectional area of LVOT multiplied by LVOT VTI, and flow at aortic valve will be aortic valve area multiplied by aortic valve VTI. And if we are using the velocity, then cross-sectional area of LVOT multiplied by velocity of blood, peak velocity of blood at LVOT, equals aortic valve area multiplied by peak velocity at aortic valve. So this is how we can calculate the flow. This is summarized. How can we calculate the cross-sectional area? The cross-sectional area formula is pi r square, and we all know that radius is equal to diameter by half of the diameter, so d by 2. So if we put this value in place of r, that makes pi d by 2 ka whole square. That makes it pi d square over 4. And if we divide pi by 4, that makes it 0.785. 3.14 divided by 4 equals 0.785. So we can say that the cross-sectional area equals pi r square, or pi d square over 4, or 0.785 d square. All these three values can be used to calculate cross-sectional area at any point. In order to calculate the aortic valve area, we know that flow at aortic valve equals flow at LVOT. We have already discussed that. Flow at aortic valve can be calculated by aortic valve area multiplied by Vmax or VTI at aortic valve equals cross-sectional area of LVOT multiplied by Vmax or VTI at LVOT. If we divide this value by Vmax at aortic valve, then we'll be able to get aortic valve area. So aortic valve area will be equal to cross-sectional area of LVOT multiplied by V1 velocity at LVOT or VTI at LVOT divided by velocity at aortic valve or VTI at aortic valve. Cross-sectional area at LVOT can be calculated by either of these formula. Pi multiplied by square of radius of LVOT, or pi multiplied by square of diameter of LVOT divided by 4, or 0.785 multiplied by square of diameter of LVOT. Cross-sectional area of LVOT can be calculated by either of these formula. So I have put an example here. A 72-year-old man with history of hypertension and diabetes is short of breath on walking a flight of stairs and doing his daily activities for the previous 6 months, and is getting worse. Echo showed LVEF of 30%, calcific AS with V2. V2 means velocity at aortic valve is 3.5 meter per second, aortic mean gradient of 30 millimeter of mercury. V1 means velocity at LVOT, stroke volume index of 32, and LVOT diameter of 20 millimeter. Normal coronary zone, coronary angiography, what is the approximate aortic valve area by continuity equation. This is the formula we have already discussed. So just put the values in this formula and we'll be able to get aortic valve area. LVOT diameter equals 20 millimeter or 2 centimeter. We always use the dimension in centimeter if we are calculating aortic valve area, as the area will be in centimeter square. So we should convert the millimeter into centimeter. Then V1 at LVOT, V at LVOT is 0.8 centimeters, 0.8 meter per second, and V2 velocity at aortic valve is 3.5 meter per second. Always use the V or VTI in the same units. The both should be in the same units, either meter per second or centimeter per second. The units should not be different. Then putting the values here in the formula, we will be using this formula for cross-sectional area, that is pi into square of diameter of LVOT divided by 4, multiply by V1 at LVOT and V2 at aortic valve. As we all know that diameter of LVOT is 2, so the 2 square of 2 equals 4, and value of pi is 3.14, multiply by 0.8 V1 and 3 divided by V2, that is 3.5. So this 4 will be cancelled by this 4 and aortic valve area will be, the aortic valve area will be equals 3.14 into 0.8 divided by 3.5, that makes it 0.7 centimeter square. So this is how we calculate the aortic valve area by continuity equation. If anyone of you still have any difficulties or point to discuss, you can always discuss with me. Thank you.